Now we have an important relationship. एक relation हम लोगों ने पढ़ा था enthalpy of formation and the enthalpy of reaction. Another important relationship that we are going to study is between the enthalpy of reaction and bond dissociation energy or bond enthalpy. Fine. Please write the heading with me. Relationship between delta H naught reaction and delta H naught bond. ठीक है, तो इसको भी जरा अच्छे से समझिएगा. Here we have reactant. Here we have reactant A2, which is getting converted into B2. Fine. So give me a second. We are going from A2 to B2. So obviously, what we are doing here, we have AA bond. Here we have AA bond, and we are destroying this bond. Does it make sense? Yes or no? Please tell me. बोलिए जरा. And what is happening with this BB bond? This is getting formed. Make sense? Yes or no?
Yes.
Right. So when we are destroying the AA bond, that means we are breaking the AA bond, and breaking of bond is denoted by the bond enthalpy, energy required to break 1 mole of a particular type of bond. So in this case, we are breaking 1 mole of AA bond. So this particular process of breaking the bond will be represented by delta H naught AA. Does it make sense? Yes or no? Please tell me.
Yes, sir.
And formation will be opposite of destruction, will be opposite of destroying, and then this will be delta H naught BB, and this will be negative because we are, what is this delta H naught BB? It is the energy required to break the BB bond, but we are forming the negative sign. Does it make sense? Yes or no? Please tell me.
Yes, sir.
So every reaction, we can say that it is the sum of two things. Delta H naught reaction will be equal to delta H naught of the reactant bond. ठीक है, reactant bond minus अगर आप plus the delta H naught plus, लेकिन क्या, this thing, what is happening here, negative delta H naught product. So we can say that enthalpy of a reaction, it is equal to the sum of the bond enthalpy of reactant minus, because plus minus minus हो जाएगा minus the sum of the enthalpies of product. Please write this down. Raise your hand once you are done. Waiting for Abir, Ali, Jasleen, Shaima, and Zainab. Okay, everyone is done. Now, write a question. Calculate enthalpy of reaction of the following reaction using given data. CH2 double bond CH2 plus 3O2 gives 2CO2 plus 2H2O. ठीक है? So this is the reaction and आपको data दिया हुआ है. You have been given the bond and their bond enthalpies. So for CH bond, the bond enthalpy is 414. For the carbon double bond carbon, the bond enthalpy is 619. For carbon double bond oxygen, the bond enthalpy is 724. For OH bond, the bond enthalpy is 460. And for O double bond O, the bond enthalpy is 499. Okay. All of these will be a positive value because energy is required in breaking the bond. अब यहाँ पे and we have to calculate the enthalpy of this reaction. And delta H naught R is being asked. So how we are going to solve this? Please see. We know that enthalpy of any reaction can be written in the terms of its bond enthalpy. It will be equal to, tell me what, summation of, you have written the formula. Can you please speak that formula? तो याद हो जाएगा आप लोग को. Tell me summation of this bond enthalpies of, summation of bond enthalpy of what? Tell me guys.
Reactant.
Of reactant minus the summation of the bond enthalpies
of product.
Of product. Of product. Huh? And let me just remind you, bond enthalpy is the energy required to break what? To break, read in your notes, flip one page, you will get the answer.
To break any
माइक ऑन करके बात करें प्लीज, स्पेस बार मत दबाएं जी. Tell me Zainab.
1 mole of a bond.
1 mole of a particular type of bond है ना, 1 mole of particular type of bond. ठीक है, very good. So यहाँ पे सुनिएगा जरा, what type of bonds are being broken here? So यहाँ पे आपके पास what are the types of bond in the CH2? So here we have two types of bond. I hope you can see that there are CH bonds. Can you see that? Yes or no? Please tell me.
Yes, sir.
Yes.
How many CH bond is there?
2.
Now in 4. Can all of you see that 4? Here we have 2 and here we have 2. Make sense? Yes or no? Please tell me.
Yes, sir.
Right. Here we have 4 CH bonds. And how many? Here we have how many C double bond C? How many C double bond C?
1.
Correct. 1 C double bond C. And what else? What else do we have here in the reactant side?
O double bond O.
How many O double bond O?
3.
Okay, just give it a second. एक second. We have 3 OO bonds. 3 O double bonds O. Fine. The sum of these minus, what are the bonds in product? Can you tell me guys? In CO2, how many C double bond O is present?
2.
2. Yes. And how many CO2 is present?
2.
2. So we have 2 and 2 into C double bond O. Complete explanation is there. Make sense? Yes or no? Please tell me.
Yes, sir.
We have 2 CO bonds in 2 CO2. Fine. Plus, what about H2O? What type of bond is present in H2O?
OH bond.
Not double bond, OH bond. How many OH bonds?
2 OH
2.
bond.
2 OH. So can I write like directly 4 OH because we have 2 water molecules. Does it make sense? Yes or no? Please tell me.
Yeah.
Yes, sir.
Okay, now we are going to plug in the values. This will be 4 into what? What is the CH? 414 plus C double bond C has a value of 619 plus 3 into O bond is 499. I'm writing 500 for fast calculations. यहाँ पे 4 into C double bond O is how much? 724 plus 4 into OH bond is 460. Can you calculate this value? Yes or no? Please tell me. हो जाएगा?
Yes, sir.
Copy this down. Raise your hand once you're done. Calculate the values and then raise hand. Yeah. आप लोग तो raise hand. You are raising hand. Seems like you are done. Calculate this and then raise hand. Once you are done, send the answer on my WhatsApp. Yeah, approximately correct. I'm very good. सही है. Approximately क्या सही है हमको लगता है. ठीक है. This value will come out to be minus 961. And this will be in whatever unit these values are in. If these are in calories or kilojoule or joules, whatever the value is in that unit. So I'm just writing units. Okay, you just need to copy this unit, whatever the unit is present here. 962 आ रहा है, 61 ऐसे ही कुछ आएगा, 961 62, doesn't matter too much here. Waiting for Alina, Jovita, and Zainab. Zainab, you're done, na? You can raise the hand. Waiting for Alina and Jovita. Okay, everyone is done. Now, right next, enthalpies of physical transformation. No, unit will be whatever the unit is there. You have not written the units for these, na? Whatever the question is saying, the unit will be that. I mean, these values, they will be having certain units. The same unit for the answer also. Got it, Zainab?
Yes, sir.
I don't remember like what these units are in. है ना? Right, next, enthalpies of physical transformation. Enthalpies of physical transformation. Solid gives liquid. So this is fusion. So this is known as enthalpy of fusion. Enthalpy of fusion or delta H naught FUS. है ना? Fusion. If liquid is getting converted to gas, then this is vaporization. So this is known as H naught of vaporization. Standard enthalpy of vaporization. Third one, if you are going from 1 mole of solid to respective gas, then this is enthalpy of sublimation. Now third हो गया, fourth लिखिएगा enthalpy of hydration. What is enthalpy of hydration? The enthalpy change, that is delta H, when 1 mole of gaseous ion is hydrated in water. ठीक है? So for example, 1 mole of sodium positive, तो आप अगर पानी में डालिएगा, then it will become what? Sodium positive aqueous. So the heat is released or heat is required in this particular process, it is known as the enthalpy of hydration. Similarly, Mg2 positive will be dissolved in water and it will get converted to Mg2 positive aqueous. And similarly, you can have Cl negative also gets dissolved in water and you will get Cl negative aqueous. Right. So all of these reactions, like whatever enthalpy or whatever heat is released or absorbed, these type of changes, it is known as enthalpy of hydration. Then you will write fifth part, enthalpy of dilution. So enthalpy of it is denoted by delta H naught hydration. Enthalpy of dilution, it is denoted by delta H naught DIL. Sorry, excuse me guys. Alhamdulillah. can write the enthalpy change when 1 mole of an compound dissociates into its ion in gaseous state. एक सेकंड रुक जाइए जरा, लिखा दिया कुछ, एक सेकंड, डोंट राइट दिस पार्ट, this is an lattice enthalpy लिखा दिया, एक सेकंड, read it like this: enthalpy change in dilution है ना, specific amount. I was thinking about, I was lattice enthalpy लिखा दिया, specific enthalpy of dilution, specific amount of solute is added to specific amount of solvent. So that is known as enthalpy of dilution when you are diluting something. Okay. Now these are very small things. Just need to remember the names and that is it. ठीक है, बहुत ज्यादा इसमें कुछ टफ नहीं है. The next one is quite important, that is lattice enthalpy. Lattice enthalpy is going to be one of the last enthalpies that we are. उसके बाद हम लोग फिर आगे बढ़ेंगे. So please copy this down. Raise your hand once you're done. Waiting for Alina and Jobita. Just waiting for Jobita. These enthalpies, ना ये जो 5 enthalpy है, this should be in your notes and please just keep revising this. है ना, if they ask directly what is enthalpy of hydration, then you should know enthalpy of hydration, enthalpy of dilution. That's it. What is enthalpy of fusion, vaporization, sublimation? They can ask directly. ठीक है? हाँ, although these will be used here and there, you just need the meaning of these things. You don't need to get into the details or the examples. तो आपको खुद समझ में आ जाएगा जहाँ जहाँ इस्तेमाल होगा. Like we are going to use it in the lattice enthalpy itself. तो वहाँ पे आपको समझ में आ जाएगा how it is going to. Raise your hand once you're done, guys. Jovita, I'm just waiting for you. Jovita, कितना लिखा आपने? 10, Jovita? Jovita, let me. अच्छा 1 minute. आप हैं तो कुछ बोलिएगा ना प्लीज. लग रहा है ही नहीं. That ठीक. अब यहाँ पे important part है, that is lattice enthalpy. Please write the enthalpy change when 1 mole of an ionic compound dissociate into its ions in gaseous state. Basically, if you have, for example, NaCl, now this is important. NaCl, okay, if you break it into Na positive gaseous state में plus Cl negative in the gaseous state, this will require certain energy, and that is known as the enthalpy of reaction, delta H lattice. Enthalpy of lattice enthalpy ना बोल रहे हैं हाँ lattice enthalpy delta H not lattice, fine. So it was okay. Then we are going to learn one more thing, that is the Hess law or the Born-Haber cycle, which is used to determine the lattice enthalpy. Alina, just waiting for you. One way of getting Na positive and Cl negative gaseous ions through NaCl. We can also get Na positive and Cl negative if I let us suppose have sodium atom which is in solid state, और इसको हमने क्या किया, I turn it into gaseous state, ठीक है, I turn it into gaseous state Na, gaseous state. This would require the enthalpy of sublimation delta H naught. Wait a second, इसको ऐसे कर देते हैं. We have sodium solid and we are converting this to sodium gas. So this will require enthalpy of sublimation. Let me write this in different colors. Delta H sublimation. Now we need Na positive, so we can remove one electron from sodium, gaseous atom of sodium, and this is ionization enthalpy that we have learned. Sodium से sodium positive कर लिया ना हमने by removing an electron, and we have to remove the electron only from where we can remove the electron from neutralized gaseous atom है ना, तो gaseous atom से आपने electron निकाला, and that will be defined as नीचे क्या हो जाता है इसको, that will be defined as delta H naught ionization enthalpy. Now we can also get chlorine negative by what, if I have, let us suppose, half Cl2, and first of all you break the bonds. So how many bonds we are breaking? If we had 1 mole of Cl2, then we would be breaking 1 mole of Cl bonds, Cl bond, but right now we have half mole, so we are going to break only half moles of Cl bond. यहाँ पे जो delta H naught of chlorine होगा, that will be half, because we are breaking only half moles of the bond. Then you will get chlorine gas. How many moles? 1 mole of chlorine gas, because initially also we had 1 mole of chlorine Cl2 gas. Here we are going to get 1 mole of Cl gas. And if you are going to add one electron, this would involve the enthalpy, electron gain enthalpy. So Cl say Cl negative. This is going to involve what? Electron gain enthalpy delta Heg. Okay. Now, if you see here, sodium plus half chlorine, it will give you what? It is going to give you 1 mole of NaCl solid also. है ना? And this is what enthalpy of formation. Okay, this is delta H naught F. Now, whether you go from NaCl to Na positive and Cl negative via this pathway, directly, in this way you are going to Na positive and Cl negative directly. But if you follow this pathway, then you are going indirectly. Does it make sense? Yes or no? Please tell me.
Yes, sir.
Now we know that enthalpy is what delta H. It is what it is a state function, and it is not going to depend on the path. It is only going to depend on the initial and final state. So this is my initial, and this is my final. No matter how I am going to get the lattice enthalpy. Right? So this what we can say the lattice enthalpy. This is the delta H naught lattice. This is the lattice enthalpy, and this lattice enthalpy can be what can be determined like this. Please see here. Okay. NaCl से first of all I will go in the opposite direction. This is delta H naught F. Opposite जाइएगा आप. Fine. तो ऐसे लिखिए देखिए. Delta H naught lattice. Like this, and then you have to go down. है ना? So tell me, in the first step, NaCl say Na solid and half Cl2. The enthalpy of formation, it is in the same direction or the opposite direction. In our process, it is in the same direction or opposite direction. Enthalpy of formation वाला जो direction. This arrow represents enthalpy of formation, and I am going in this direction. It is same or opposite?
Opposite.
Opposite. If you take the negative of enthalpy of formation, because it is opposite of the formation reaction. Delta H naught formation का negative. Now, when let us suppose we are taking the Cl case. So sorry, we are taking the sodium case. है ना? तो sodium में delta H naught sublimation का arrow देखिए, and then look at the arrow in which we are going. They are same or different? Same, na? Same, so it will be what? Delta H naught sublimation. So what about delta H naught ionization? Same or different? Delta H naught sublimation. So get delta H naught ionization. Same or different? अरे क्या हो गया? What happened, guys? Same, na? This is how we are going, na? ऐसे है. Means see the arrow of the reaction, see the arrow of the our direction. This is also same. So enthalpy of ionization. Now plus, tell me, bond enthalpy जो है, this part, this is same or different? बोलो, same or different? Same, right? They're going in the
Same.
this direction. हाँ, same तो है. क्या इतना टाइम लगा रहे हैं आप लोग? So it will be delta H naught Cl divided by 2 plus even electron gain enthalpy is in the same direction. So delta Heg will be like this. So this is what's known as the Born-Haber cycle. And please write this down. उसके बाद एक Hess law है that we will also write. Waiting for Abir. Zainab. Okay, doctor. Tell me. Right, next, Hess's law. Hess's law is the same thing that we have just applied here. Hess's law, it says that, please write with me, the delta H reaction is same. So can I explain the CL part? हाँ, fine. Zainab, can you please turn your mic on? हम पूरा ही समझा देंगे. Answers नहीं आ रहे थे तो हमको लग रहा था समझ में आ रहा है या नहीं आ रहा है.
Yes, sir.
Okay. So first funda is that whether we go in this direction and then reach NA positive and CL negative, or we reach positive and CL negative directly, it is going to give us the same value. Make sense, yes or no?
Yes, sir.
Okay. Now, just look at the arrow that we are moving on, and then look at the arrow of these reactions and these changes. So from like you, I think your the difficulty starts from here itself, right? CL2, right, Zainab?
I understood the half CL part.
So you understood, very good. Okay. Then what we did not understand?
Sir, why is it same in the chlorine case?
Why it is?
Same in the chlorine case, like,
In order to go from NaCl and get Na positive and Cl negative, we have to move in this direction. No?
yes, sir, got it.
Got it?
Yes.
The delta H for a reaction is same whether the reaction occurs in one step or multiple steps. Next point. Delta H is independent of path. Therefore, it is a state function. अच्छा एक चीज आपको बता देते हैं. This whole thing, this is known as Born-Haber cycle. ठीक है. If you have any space left ना, तो इसको लिख लीजिएगा. This is known as Born-Haber cycle. Yes. Another enthalpy is enthalpy of solution. Okay, this is also normal, but a bit more important. Sixth degree of enthalpy of solution. That is delta H naught solution. यहाँ पे दो एंथैल्पीज में ना जनरली बच्चों को दिक्कत होती है, एक एंथैल्पी ऑफ सॉल्यूशन, द अदर वन इज एंथैल्पी हाइड्रेशन. तो व्हाट इज द डिफरेंस? ना सॉल्यूशन करना या फिर हाइड्रेशन करना, देन व्हाट इज द डिफरेंस? द ओनली डिफरेंस इज इन द स्टार्टिंग मटेरियल. अगर आप हाइड्रेशन में देखेंगे तो हाइड्रेशन में आपके पास क्या है, स्पेसिफाइड दैट द सब्सटेंस शुड बी gaseous ion, should be gaseous ion, but in the enthalpy solution it is just 1 mole of any substance, है ना? So the delta H, the enthalpy change when 1 mole of a substance is dissolved in a given amount of solvent. In a given amount of solvent. ठीक है. So for example, if you have NaCl solid, if you're dissolving this into, and it is getting Na plus aqueous plus Cl negative aqueous, then this, whatever change is happening here, this will be delta H naught solution. That will be delta H naught solution. Now this, how can we calculate the enthalpy of solution? First of all, आप इसको break कीजिए पहले किसमें, in the gaseous ion. So Na positive gas plus Cl negative gas, and then you add water to this. So this process of going from NaCl solid to its constituent gaseous atom, this can be calculated from the lattice enthalpy. This will be delta H lattice. And gaseous ion, when you add water and make it aqueous, then this can be represented by delta H naught hydration. Does this make sense? Yes or no? Please tell me.
Yes.
Copy this down, raise your hand once you're done. So from here you can say that for this case, enthalpy of solution is equal to the lattice enthalpy plus the hydration enthalpy. चलिए कुछ क्वेश्चंस करते हैं आप. Waiting for Abir, Jobita, and Zainab. Write this down. Shaima, आपका नहीं हुआ था क्या?
No, sir, I'm done.
You're done now. Okay. सवाल लिखिए फिर हम समझाते हैं। अच्छा सवाल है। वेटिंग फॉर अलीना, जसीम, शाइमा एंड जैनब। चलिए, सी है। In this case, they are asking calculate the enthalpy change on freezing 1 mole of water. What is after to at? No, wait a second. क्या छूट गया इसमें? हाँ हाँ, it is at. ठीक है. So calculate the enthalpy change on freezing 1 mole of water at 10 degrees Celsius. So you have to start from water at 10 degrees Celsius. So obviously it is going to be liquid. 10 degrees Celsius. Water solid at minus 10 degrees Celsius. ठीक है. Now this would involve a series of steps. Directly आप नहीं चल जाएंगे. And I mean you can go directly obviously. ऐसा नहीं कि आपको रुकना पड़ेगा कहीं पे. But by the given data we have to stop at some time, some steps. For example, I will go from H2O to H2O liquid from 10 degrees Celsius to 0 degrees Celsius. पहले तो हम यहाँ पे जाएंगे. H2O गैस नहीं, H2O गैस कहाँ से? H2O liquid. H2O liquid at 0 degrees Celsius. After that, we are going to convert this water to from liquid to ice. We convert करेंगे ice में. That is H2O solid at 0 degrees Celsius. This would require certain heat changes. Then we are going to again cool it down to minus 10 degrees Celsius. So this is, let us suppose, the delta H of, like, whatever the delta H of the change or reaction. This is the first enthalpy, this is the second enthalpy, delta H2, and this is delta H3. So according to the Hess's law, if we go directly or indirectly, the same energy will be used. So delta can be written as delta H1 plus delta H2 plus delta H3. यहाँ तक बताइए, does it make sense? Yes or no? Please tell me.
Yes, sir.
Yes.
अब हमको देखना है what is delta H1, what is delta H2 and what is delta H3. Any idea? थोड़ा सोचिए जरा.
Delta H1 is 0 degrees Celsius. Delta H2 is minus 10 degrees Celsius. Delta H3 is 0 degrees Celsius. Delta H1 is 0 degrees Celsius. Delta H2 is minus 10 degrees Celsius. Delta H3 is 0 degrees Celsius. Delta H1 is 0 degrees Celsius. Delta H2 is minus 10 degrees Celsius. Delta H3 is 0 degrees Celsius. Delta H1 is 0 degrees Celsius. Delta H2 is minus 10 degrees Celsius. Delta H3 is 0 degrees Celsius. Delta H1 is 0 degrees Celsius. Delta H2 is minus 10 degrees Celsius. Delta H3 is 0 degrees Celsius. Delta H1 is 0 degrees Celsius. Delta H2 is minus 10 degrees Celsius. Delta H3 is
देखिए डेल्टा H1 में वी आर हीटिंग इट, मेक सेंस, यस और नो?
Yes.
So delta H in this case can be, see here, we are changing the temperature from 10 degrees Celsius to 0 degrees Celsius. Just give me a second. Sorry, guys, someone was at the door. Am I audible?
Yes, sir.
Yes.
Okay. So what we are doing in the first step is we are cooling the water. है ना? We are cooling the water. So in cooling the water, what is the temperature change? Can you tell me what is the delta T? Mm-hmm. बोलो. What is the delta T? What is the temperature change in the first step? जोर से बोलिए. अरे आसान है, दिख रहा है, ये तो बहुत ही आसान है.
10 degrees Celsius.
हाँ, that is true. But plus 10 or minus 10?
Minus 10. Minus 10.
Minus 10. Why minus 10? Delta T will be equal to final minus initial, है ना? पक्का?
Yes, sir.
What is the final?
0 degrees.
0 degrees. Minus, what is the initial?
10
10.
degrees Celsius.
10 degrees. So it will be what? Minus 10.
Minus
Does
10.
it make sense? ठीक.
Minus 10.
Okay. Minus
Yes,
10
sir.
degree. Minus 10 Kelvin will be the change. अच्छा. अब उसके बाद now this यहाँ पे जरा पढ़िए यहाँ पे. Water, the heat capacity of water is what? 75.3 joules per mole per Kelvin. So for each Kelvin, how much energy we have to give? For each 75.3. ये तब देना पड़ेगा. You have to give this much amount of energy when you have to raise the temperature. Does it make sense? Yes or no?
Yes, sir.
Sir.
है ना? But here what we are doing? Here यहाँ पे क्या कर रहे हैं हम लोग? Here we are decreasing. यहाँ पे simply for decreasing what we have to do? Just negative sign. जब आप heat कर रहे हैं तो आपको इतनी energy देनी पड़ेगी. जब आप क्या कर रहे हैं? When you are decreasing the temperature, that means heat is given out from the system. So this enthalpy will be for each Kelvin 75.3. So for 10 Kelvin, I hope you remember the degree Celsius and in Kelvin, the change is same. So for 10 Kelvin, it will be what? Simply 75.3 into minus 10. That will be equal to how much? Minus 753. Make sense? Kilojoule or joule? Joule. Correct है ना? बोलिए. Does it make sense?
Sir.
Yes, sir.
नेक्स्ट में क्या हो रहा था बताइए. दिस डेल्टा H2 क्या रिप्रेजेंट कर रहा है?
No change in temperature.
टेम्परेचर कुछ तो चेंज हो रहा है. व्हाट इज चेंजिंग?
State from liquid to
हाँ, from liquid to solid. So from liquid to solid, so what will we say? What is happening here?
It is becoming solid.
Sorry,
It is becoming solid.
it is becoming solid. But what is the enthalpy change? मतलब, is there any data that is given which we can use?
Yes.
Which data? Tell me. It is going from liquid to solid, which is opposite of solid to liquid. Fusion का data दिया है, right? They have given us the enthalpy of fusion of water, but what enthalpy of fusion क्या होता है? Fusion is solid to liquid,
Solid to liquid.
है ना? But we have been given liquid to solid, तो बस इसका उल्टा कर देंगे, हाँ या ना? Make
Yes,
sense?
sir.
This
Yes,
is your
sir.
delta H. Delta H2, it is equal to negative of delta H fusion. Correct? So this is delta H2. And delta H2 can be written as what? Minus will be कितना हो जाएगा ये? Minus 6030 joules. Does it make sense? Yes or no?
Yes, sir.
ठीक है. And वही अब देखिए third case में क्या हो जाएगा? Delta H3 is very similar to that of the delta H1. In this also we are changing the temperature, but here the change of temperature is what? We are going from 0 to minus of minus 10. That will be equal to how much? Tell me.
10 degrees.
10 degrees Celsius, right? Will be equal to 10 degree Celsius. So this is positive 10 now, है ना? So positive 10 के लिए क्या करेंगे? We just are going to multiply here, so it will be equal to what? 300 minus of minus 10 degree Celsius. सही कर रहे हैं हम? सही है ना? Yep. So it will be 36.8 into positive 10. Equal to how much?
360.
368. Yeah. एक सेकंड. हाँ. This will be equal to 368 joules. तो जरा कैलकुलेट कर लीजिए कितना आ रहा है आंसर. एक सेकंड बस थोड़ा सा रुकिएगा. आई एम जस्ट अ बिट यहाँ पे भी डिग्री टेम्परेचर ना. आई एम अ बिट कंफ्यूज. माइनस 10 केल्विन में लेते देन आई थिंक इट विल बी हियर आल्सो टेम्परेचर इज डिक्रीजिंग. ठीक है सर. 273 माइनस माइनस 10 डिग्री सेल्सियस कितना हो जाएगा? 260, राइट? है ना? 273 से 263. यहाँ पे कैसे जाएगा? 10 डिग्री 273 से 263. ओ नहीं 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 नहीं, दिस विल बी आल्सो. एक सेकंड रुक जाइए, बस रुक जाइए. फाइनल माइनस इनिशियल ना. फाइनल माइनस इनिशियल उल्टा कर दे रहे थे अब. फाइनल minus initial. Final is minus 10, initial is 0. So the delta t in this case will also be minus 10. In this case also it will be minus 10. हाँ? यहाँ भी minus रखिएगा please. Be minus 368. तो अब add कर दीजिए दोनों को, you will get the answer. Yes. Yes, Shaima correct, very good. सही है. Calculate the answer. It will be minus 7151. Add all the delta H1, H2, and H3. हो गया सबका? Raise your hand if you're done, guys. ठीक है, तो delta H will be equal to minus 753 minus 6030 368. Everything is in joule, and this is coming as minus 7151 joule. Waiting for Alina and Jasleen. ये गई है. This is very similar to what we did in the last lecture regarding enthalpy of formation. So the relationship between enthalpy of formation and enthalpy of reaction उसी से आ जाएगा. Try this. Waiting for Jasleen, Shaima, and Zainab. Now please do the questions, guys. This question को कीजिए, हाथ ही रेस कर रहे हैं सिर्फ अभी तक. आई एम नॉट गोइंग टू एक्सप्लेन दिस. पहले थोड़ा ट्राई कीजिए इसको. अच्छा, let me know who is trying. Please just tell me that I am trying. Hopefully a few people are at least trying. It's very similar to it in the last lecture. ठीक है, enthalpy of formation and enthalpy of reaction के बीच में you just need to मतलब plug in the formula and the values, that's it. Okay, did I get answers? Shaima and Jasleen are trying. Okay, fine. Okay, I will give you 3 more minutes. Two more minutes. One more minute. We have got an answer. Jasleen got an answer. Yes, very good, Jasleen. It is correct. Yes, very good, Zainab. Very good, Jobita. KG नहीं KJ. Right, Jobita?
Yes, sir.
It will be not kg, it will be kj, kilojoule.
Yes,
Okay नहीं समझ में आया कि नहीं आपको? Got it?
yes,
See? Make
yes,
sense?
sir.
हाँ,
Yes.
kj, kilojoule. 780 it is also fine, Zainab, approximately. ठीक है. So this is how we are going to solve it. Enthalpy of reaction. Shaima नहीं. कैसे किया Shaima? Can you please tell me? Turn your mic on, Shaima. Shaima, can you please turn your mic on? हाँ बोलिए. कैसे किया? Enthalpy of a reaction is equal to
Summation of enthalpy of bond of the reactants.
bond. Enthalpy of bond तो दिया ही नहीं है. What has been given? Enthalpy of
Formation.
formation. So product gets formed. So delta enthalpy of the formation of product, है ना? And reactants get destroyed. So minus the sum of the enthalpy of formation of reactant. So enthalpy of formation के लिए आपके पास क्या क्या है प्रोडक्ट में? N2O. तो N2O has this is 1 2 3 1 2 3 81. right? 81 plus. अच्छा, how many N2O? One N2 है, and N2O ना, 1 2 3 is N2O, हाँ ठीक है. Then we have 3 CO2, so 3 into CO2. Enthalpy of formation of CO2 1212 is minus 393, minus 393 minus sum of the enthalpy of formation of the reactant. Reactant में we have N2O4 which has the enthalpy 9.7 plus, हाँ ए ओ माय गॉड, माय बैड, minus 393 नहीं करना चाहिए था. CO is the first one, that is minus 110, minus 9.7 plus we have 3 CO2, that means 3 in minus 393. ठीक है, whatever will be the answer, it will be in kilojoules only, है ना, kilojoule per mole, all the values in kilojoules per mole. इसको बस कैलकुलेट कर लेना था. मेक सेंस? यस और नो, प्लीज टेल मी. शाइमा, समझ में आया आपको?
Yes, sir.
चलिए कॉपी दिस डाउन गाइस. N2O4 का कितना है? N2O4 is 9.7. ओहो, नहीं नहीं, एक सेकंड रुकिए जरा, मिस्टेक हो जा रहा है बार बार, आई थिंक. मिस्टेक हो गया ना जसलीन? ये हमने सही लिखा था यहाँ पे. दिस विल बी 393 एंड दिस विल बी 110. 9. ठीक है, 9.7. और CO के लिए कितना है? minus 110, so this will be in the negative 110. और N2O का कितना है? 81 and CO2 is how much? minus 393. this will, ये होगा, प्लीज इसको कॉपी कर लीजिए गाइस. थोड़ा सा हमसे कभी इधर उधर हो जाए तो प्लीज लेट मी नो. Copy this down. The answer that you're going to get, it will be 777.7 kilojoule. Yeah, sir. If you round up the result, will also. A better person is to ask. Better person for this question is your teacher, Zainab. ठीक है, अगर जैन आपकी टीचर है थोड़ी lenient है अगर, then they would give marks, but if they are very strict about everything, then they are not going to give the marks. But मतलब hopefully generally में इतने strict नहीं रहते टीचर्स. They want to know the concepts, है ना, तो hopefully you will get the marks. अगर हमसे पूछे then I will give the marks if you are decimal points. आंसर इतना ही आ रहा था ना, -777. Justine, I have to discuss your papers, right? Did you get the information? Yes, Justine.
So they told me to join one link at
हाँ
5
थोड़ा.
o'clock.
हाँ.
Didn't tell me like why.
अच्छा, they did not tell you why. अच्छा, we have to discuss your test paper. आपके स्कूल में एग्जाम कब है?
Sorry, sir.
आपके स्कूल में एग्जाम्स, व्हेन इज योर स्कूल एग्जामिनेशन, हाफ ईयरली?
1 second.
No problem. Hmm. Yes, Jasleen.
So it's at 7th of October.
अच्छा ठीक है, we have time. Okay. So I have your paper in front of me. Zainab, Shama sir, my first term examination is on 17th of October, and it has only the first four chapters. Sir, my half yearly examination is at